the bullet didn't fire, and so they didn't get very much of a sample, just a few grains on the first attempt back in 2003. But this time it seems to have been much more successful. And so they were then able to go for the even more outrageous part of this mission, which is really, I think, quite mind-boggling in its audacity. Here's the view from Hayabasa as it comes down to make this sample grab. I draw your attention to these three rocks here because you'll see them again in the next picture. In the next picture, they will have moved up to about here, but the target at the landing area is about here. So this is the before picture as Hayabusa comes down, and this is the after picture. There's those three rocks I mentioned, and you can clearly see that there's been quite a significant amount of disturbance on the surface while Hayabusa touched down and fired this little bullet. So we'll just jump you back. Before, after, before, after. So you can see there's quite clearly been a disturbance on the surface, which is a good indication that they've managed to grab a decent sample. So then they go into this even more outrageous part of the mission, which is to try and sample below the surface. Now, one of the problems with a sample grab, if you just get a few millimeters of surface dust, is that the outer surfaces of asteroids have been baked by constant exposure to sunlight for many, many years. This is a process which is called space weathering and was highly controversial when it was first proposed back in the 80s or so. But we now accept that space weathering really does occur, that the sun bleaches and changes the chemistry of the surface of an asteroid quite considerably. So if you want to know what the asteroid's really like, you've got to get underneath this top crust that's been baked by the sun and try and get some older material that hasn't, well, it's the same age, but it hasn't been exposed to the sun for any length of time. And to do this, Hayabasa launches a special thing called a small, it's called the SCI, the Small Compact Impactor. That's the thing in the bottom left-hand side, bottom left picture. And this is what's called a shaped charge. Now, those of you who are familiar with firing bazookas at tanks will understand what a shaped charge is. If you have a piece of plastic explosive and it's a ball and you explode it, all the energy goes out in different directions. But if you shape the plastic explosive into a form of a cup, when it ignites, the cup shape focuses the blast all in one direction, and this focuses the beam of energy, focuses all of the energy. And that's why they use them. They use them in bazookas because they focus the shape charge focuses the explosive charge into the side of the tank. So what they did with this small compact impactor is they have a shaped charge, and when it fires, all of its energy is directed in one direction, and that in turn throws a copper plate at the asteroid. So the stories about them exploding a bomb on the asteroid are not correct. The explosion occurs above the asteroid. It's a sheet of metal which is then fired down to the this down background is changing again. It's a small slab of metal which is fired down into the surface to create a crater. And they also have this on the right-hand side. You can see what else is going on. They deploy a small camera, which is a free-flying camera, which is to observe the explosion. And the main spacecraft runs away around the backside of the asteroid and hides, so it's not damaged by any debris thrown up by the explosion. And here's the picture of the compact, the image of the impactor being released. Let's see if that makes it better. So that's the thing with the shaped charge and the copper bullet in it being released from the mothership. A couple of hours later, this explosive charge fires, chucks the metal plate into the asteroid, and this is what the little orbiting camera shows. If you look here, you can just see on the edge of the asteroid what looks like a plume, and magnified up here is the same bit of the image, and you can see that the impactor has indeed struck the surface and thrown up a plume of material. So there probably is a crater being formed, and the spacecraft then just has to go back and look for it. So once the dust has settled, as it were, Hayabusa comes out from hiding behind the asteroid and goes to look for the crater. And here it is. They do find it. And here's the before picture. There's this rock here. And here's the after picture. There's the rock still there, but now there's clearly a crater that was not present a few days earlier. So this is fresh material that's been excavated by the impact of this metal slug. Now this is a close-up of the impact crater. It's here. There's a 10-meter scale bar. And so now the second sample grab is made to go down and land on this area that's been disrupted by the impactor. And this, I'm pleased to say, also went extremely well. This is a still photograph of the sample horn just above the surface, just before the touchdown. And what I have next would be a video, except because I've stripped the videos out because of the internet nature of this talk. But you'll see that all heck breaks loose when the horn hits the ground, fires. All of this stuff you can see here is bits of dust or tiny bits of gravel flying in all directions. And these things are very easy to find. If you go onto the Hayabusa website, you can see these videos. You download little MP4 files or something. And there's a lot going on when this thing happens. It hits the surface, dust and bits fly everywhere, and then it starts to back away again with a sample of dust inside it. And this has gone so well that they had enough resources for a third sample grab, but they decided that having got a good clean sample before from the surface that's been weathered, and they've got a good sample from a fresh material that's been excavated by the cratering experiment, they decided not to risk a third attempt and to quit while they were ahead. So they ended the sampling at that point, and they're ready to come home. So this is the result from all this. What is all this telling us about this asteroid and how it came about? Well, the chemistry that's been revealed by the infrared and optical spectrographs imply that the material on Ryugu has been subject to aqueous alteration. So it's undergone chemistry connected with water, and that works best inside an asteroid where there's a certain amount of warmth. So what seems to have happened is, and that's the top left-hand corner of this slide here, is Ryugu starts life as part of a much larger asteroid, large enough that it traps aluminium-26, which is a radioactive material. And as that radioactive material degrades or decays, it gives out heat, and that's what heats up the center of the Earth. That's why the Earth has a molten core. Now, asteroids are much smaller, but they can still trap enough aluminium-26 to have a brief internal heating period. It's also possible to heat up the inside if you have a series of impacts, each of which dump energy on the surface, and some of which then leak inside the asteroid. But it's much harder to get a nice smooth heating that way. It's much easier to do it if you can put aluminium-26 inside and heat the whole thing up from the inside. Then what seems to have happened is that something hit the parent body and smashed it into many, many pieces. If you remember, I said at the beginning, this is how we form asteroid families. Some asteroid gets smashed up and lots of pieces fly off and stay in roughly the same orbit. So some of these things stay close enough together that after it's been smashed up, they gradually reaccumulate to form another group of smaller asteroids, each of which contains fragments from the original parent. So that's what's shown here. And then these things gradually reaccumulate to form another smaller asteroid, which is mostly made up of mangled up bits of the first one. And quite possibly this daughter asteroid then gets smashed up again by another impact to form more little clouds of rubble, which then themselves re-aggregate to finish up forming this thing, which today we call Ryugu. And that's quite consistent with what we see, because all of these images of the surface are just boulders. It's boulders of all shapes and sizes, but nothing else. So that's quite consistent with the idea that Ryugu itself is simply an aggregation of boulders which were formed by smashing up an intermediate parent body, or possibly a whole family, a cascade of ever smaller collisions which got made ever smaller asteroids to leave us with the thing we've got today. And the chemical composition of Ryugu seems to be consistent with two asteroid families, both of which are in the inner main belt, and they're the Urania or Polonia asteroid families, which are both C-type asteroid families, and are consistent with potentially being the parent, one of the parent bodies from this collisional cascade, which leaves us with this smashed up asteroid today. So that's almost the end of the Ryugu Hayabusa story. The mothership departed the asteroid in November, and it's starts on its way back to Earth. It's running on ion thrusters, so its journey back to Earth is quite quick compared to its outward path. It should return to the Earth this December. The sample canister, which is a sort of like an ice bucket, little Apollo capsule shaped ice bucket, with those two samples inside, is released from the mothership as it approaches the Earth. The mothership then executes a motor burn so that it doesn't crash into the Earth. The sample canister continues along its original trajectory, where it should land in Australia, in the Woomera rocket range in Australia in December this year. And the mothership flies past the Earth, and if it's still working after all of this, there's a possibility of sending it to another near-Earth asteroid, and this is the currently best target, 2001 WR1, where it would arrive in 2023. Now it can't, of course, it's deployed all its landers, it's done all its sampling, it can't do any of that clever stuff, but it could still put itself into orbit, image the asteroid, and do all the orbital chemistry. So if all goes well, Hayabusa 2 still has a big future, not just in returning those samples, but going off to explore another asteroid. And that brings us to the second mission in this series, which is an American mission called OSIRIS-REx, which has the most incredibly convoluted naming acronym you can think of: Origin, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. God knows how they made that up. This is part of the, I think, security bit is we need to understand near-Earth asteroids so we know how to deflect them. We've probably all seen Deep Impact, we've probably all seen Armageddon. Sending Bruce Willis with an atom bomb is absolutely the worst thing you can do if you want to deflect an asteroid, because as we've seen, they are mostly made of rocks. The density is very low. It's 1.2 for Ryugu. So that's not much more than water. So it must have loads and loads of empty space inside. It's not really a solid object at all. It's a bag of marbles held together by tiny mutual gravitational forces. You hit it with an atom bomb, you're just going to fling the bits in all directions. So that's not the way to do it. So I think that's the security bit of OSIRIS-REx. It was selected by NASA about 10 years ago as part of their New Frontier series. It's a medium-sized mission. And the plan was to go to an asteroid and return a sample. And the target for this one is 101995-955 Bennu. It's another primitive asteroid. We call it a B-type, but it's very similar to a C-type asteroid. It's another Earth crosser, so it's another potentially hazardous asteroid with a small possibility of striking the Earth in about 200 years. It's half the size of Ryugu. It's only 500 meters in diameter, rotating 4.5 hours. the orbital information's there if you want it, but it's not terribly important. It's an Apollo Earth-crossing asteroid. OSIRIS-REx has the same convoluted sort of trajectory. It was launched by an Atlas II rocket in September of 2016. It flies away from the Earth, it returns to the Earth for an Earth gravity assist, and then it's flung out by the Earth's gravity to rendezvous with its target, where it arrives about a year ago. So it arrives in December 2018, just over a year ago. It makes a few sort of drive-bys to get some basic shape information, and it finally goes into orbit on New Year's Eve 2018. And this is very, very close. Unlike Hayabusa, which was sitting 20 kilometers away, this thing is 1 3/4 kilometers above the center of an asteroid, which is itself half a kilometer in diameter. You know, this is really very, very low. So it was important to get the shape of the asteroid accurately so they could get this very precise low Earth orbits, and they low orbit around the asteroid. So they spend quite a bit of time flying around to get a good feel for what the asteroid's internal structure is like, because that's important to understand its gravitational field, which they'll need to know if they go for when they go for the sample grab. This is a picture of Bennu. If I was physically there with you, I would at this point be passing around my 3D printed model, but unfortunately I can't be with you, and my model can't be with you either, because it's in my office and I'm not allowed to go to work at the moment, for a reason I'm sure we all understand. But I have a 3D model of this thing about so big. It's quite a fun thing to have. And what you see is that, like Ryugu, like the Hayabusa target, it's very, very rocky. It's got a few big boulders. Here's one, here's another. It's covered in stones, and there's just no flat, dusty bit anywhere. This is a bit of a turn up for the book, because as with the Hayabusa mission, OSIRIS-REx was built on the assumption that the asteroid would have a surface coating of dust, which could be hoovered up, and that's clearly not the case. The first few features have been named on, this is a projection, like a Mercator projection, where you take out the whole of the asteroid and flatten it out. All of the names on Bennu are named after birds of some description. Of Bennu are named after birds. So all the Hayabusa ones are from children's stories, but these are all things to do with birds. And the first thing they did is they've gone around and named all the big stones. And you can see that, as with Ryugu, this is a very, very rocky object. These are 3 big stones. They are, the scale of this picture is NASA helpfully provided scale information. They say that this rock in the center is about the size of a pool cue. So it's about 1.5 meters, say, across. It's quite a big lump of rock. And again, you can see at all scales, just rocks and rocks and rocks. But that wasn't the biggest surprise. That was a big surprise, but it wasn't the biggest surprise that this mission produced, because quite early on, they discovered stuff was actually being flung off this asteroid. So these little white dots in this picture, they're not background stars, they're actually material being ejected from the asteroid itself. This is an amalgam of 2 photographs, a short exposure picture to bring out the body of the asteroid itself, and a longer exposure picture which shows all those little white dots, which are in fact particles 2 to 4 centimeters in diameter being ejected from the asteroid. And this was not a one-off thing. There's several of these ejection events have occurred, and the largest of them caused over 200 of these pebbles to be flung off the asteroid's surface. This, I cannot emphasize, this is a complete surprise. You expect to see stuff being ejected from comets. I mean, we went when the European Space Agency flew to Churyumov-Gerasimenko with the Rosetta mission. No one was surprised to see gas jets and stuff flying off that, because that's what comets do. But the idea of a essentially rocky asteroid ejecting material seems completely off the wall. This is a complete surprise. And there was a NASA press release that said ejection of material from asteroid explained, and I thought, great, I'll go read that. And it said there are 3 ways that the material could be ejected from an asteroid. They could be meteorite impacts occurring around the backside where we don't happen to see them, which fling stuff off. Yeah, okay, gets hit by a smaller asteroid and some bits get knocked off. Or it could be caused by water somehow building up underneath the surface and then blowing off like a little burst of steam, pushing these rocks away. Yeah, okay. Or it could be stress fracturing, where as the asteroid rotates, it gets it heats up quite rapidly, and these rocks suddenly find themselves being heated up quite a lot, quite quickly, and that introduces thermal stresses, which causes them to break apart. And that's consistent with the fact that all of these ejections seem to occur in the middle of the afternoon on the asteroid surface. So that's when the sun's been shining on it for most of the day, and it's about as hot as it's going to get. Rather disappointingly, this press release then did not explain which of the 3 mechanisms they actually thought it was. They just said it could be this, or it could be this, or it could be the other, or it could be some combination of all of them. So I thought, great, that doesn't really explain it, does it? That just tells us what it could be. We still don't really know what's causing this. But there's 3 ideas. They say we'll get more information eventually. But this is the guts of the thing, and this is the attempt to grab a sample from the asteroid. I haven't bothered to go through all this alphabet soup of all the different spectrometers and cameras they've got up there. But the thing that does the sampling is this thing called TAGSAM, the touch and go sampling mechanism. It's a bit like Hayabusa. It's essentially a trumpet on a stick that, instead of firing a bullet into the surface to kick up the dust, it will push a blast of nitrogen gas. So we'll lower the trumpet onto the surface and then puff some nitrogen gas into the trumpet in the hope of stirring up enough dust that it will fly up into the sample mechanism. And then the sample is, there's enough for, I think there's enough for 3 sample attempts. And each of the samples is then placed in this large re-entry capsule for a return to Earth. Now, the problem which they have is that the rocky nature of this object is a big issue for them, because the mission baseline was they needed a flat area 10 meters in diameter. That was how they were pretty confident they could hit somewhere within a 10-meter circle if they could find a 10-meter flat place. But it turns out there are no 10-meter flat places anywhere on this thing. The good news is that the engineers have found that they can actually control this spacecraft much more accurately than they had originally thought. So they think they can get down to within a meter of their target area. And these are the four of the target sites which were initially selected as possible target sites. They're all named after birds. So we've got nightingale, kingfisher, sandpiper, and osprey. The next picture I've got is a close-up of the kingfisher region. So having made these preliminary assessments of which ones they might go for, they've then conducted much more detailed reconnaissances of each of these target areas. This is the kingfisher site. I believe this has a resolution of 2 inches per pixel, which is the highest resolution that's ever been obtained on an extra planetary body. And you can see that even down at this very small scale, there's just rocks everywhere. So it's going to be quite an interesting experience when they finally decide to come down and do a sample grab. They have in fact picked some targets now. The primary site is this one, Nightingale, and the second one is this one, Osprey. This Kingfisher one is presumably just a bit too rocky for them to feel comfortable with. But that'll all be happening in the summer. There's nothing. There's the sampling activity is scheduled for July, and then what happens next? Well, after these two sample grabs, the return to Earth window opens about a year from now. It takes 2 years to get back. The sample return capsule, which is that little Apollo capsule-like thing, little re-entry vehicle on the body of the craft, is released 4 hours before the spacecraft reaches the Earth's atmosphere, at which point the spacecraft itself starts the maneuver so that it doesn't follow the sample return capsule down into the atmosphere. So if all goes well, OSIRIS-REx itself will fly past the Earth and go into a solar orbit, and then I've no doubt they will start working out where they can send it next. The sample canister makes a free fall into the atmosphere till it's about 30 kilometers up, and then it releases a series of parachutes, and if all goes well, it touches down in the Utah desert in September 2023. So that's where we are with these two missions. The Japanese have already grabbed their sample and on the way home. The Americans are still planning to do their grab later on this year. I think the Japanese mission's been an absolutely stunning success. Even though the first Hayabusa 1 didn't work completely as advertised, Hayabusa 2 has done pretty much everything that it said on the tin. And if you think that the Japanese Space Agency does not have the budget, anything like the budget of NASA, I think they've done a really fantastic job with this. And I just hope that the landing capsule is recovered successfully. Now, why do we bother with all this stuff? Well, I said at the beginning that these things are potential Earth impactors. Now, of course, there's no known object on an Earth impacting course at the moment, but only a few weeks ago, I stumbled across this on the BBC Technology webpage. Now, Fortnite is apparently, I don't know, I'm not of that generation, but Fortnite is apparently some sort of online video game. And according to the BBC, the new season of Fortnite has been issued because the first season, the whole world of Fortnite was wiped out by an asteroid impact. So it's clearly important to know about these asteroids so we know when they're coming and what we're going to do about them when they arrive. And that's the end. So I'll stop sharing my screen and I'll do my best to answer your questions if you've got any and if you're still there.
Okay. Pete, do you want to do the honors?
Yeah, I can do one. I'll ask one myself first of all, if I can. You said that it's fired out a little bullet. Even you were thinking that it was going to be like a more dusty item, a more dusty object. Was there any chance of that bullet ricocheting back up again? And lander?
I guess I don't know. I mean, I guess they thought of it. I mean, the thing is, the idea is just to bang it in to throw some material up, to bounce it up into the trumpet.
I was just wondering, with this, very little gravity, whether there was a possibility of that.
Well, possibly. I don't know, but I guess the engineers must have had
a bit of worry. Okay, got a question here from Eric, I think, at Astro Highlander. What size does the PHA have to be before it could be considered having an Earth extinction potential?
Yeah, okay. The Tunguska meteorite, the thing which created the Tunguska crater, which is about, the Tunguska event in 1908, was about 100 meters across, and that's what that's what I call a city buster. So it blows up a crater a kilometer in diameter, and it knocks down everything for 50 kilometers around it. The Barringer meteor crater was caused by an iron meteorite about probably half the size because it's an iron. It comes through the atmosphere and explodes on the ground. The Tunguska meteorite exploded in the air rather than striking the ground. So a city buster is about 100 meters, 50 to 100 meters in diameter. The object which caused the Cretaceous Tertiary boundary extinction, the extinction of dinosaurs 65 million years ago, was probably about 10 kilometers across. Those are 10-kilometer objects strike on average every 100 million years, so they are relatively rare. City busters probably every couple of 100 years. And as we saw only a couple of years ago, over Russia again, there was a fairly big object which came in and exploded in the atmosphere and hurt a lot of people, not because they were hit by the meteorite, but because the blast wave blew out all their windows and they were all hit by flying glass. That was only a 10-meter object. So I think to kill a lot of people, you need to be 100 meters and hit the right place. To wipe out an entire species, you need to be several kilometers in diameter.
I'm not sure if this is a question or a statement from the next one. Is one of the rocks in the US mission looked like it had a big chip off the corner? The rock the size of a pool cue.
Yes.
Okay. Darren Moody was. Go on, sorry.
I guess from what we've seen of the modeling of how Ryugu gets formed by having an asteroid which is smashed up and then reaccretes and then gets smashed up again, we're probably going to find this is a characteristic of these small asteroids, that they're all rubble piles of stuff that's been smashed up and reaggregated and smashed up and reaggregated. I mean, it can't be a coincidence that the two missions that these spacecraft have been to, the two asteroids, these look so alike.
Was the venue ejector a risk to the spacecraft?
No, they.
That's from Darren Moody.
Yeah, they did think about this, I think, as soon as they realized what was happening, but they don't seem to be too concerned. There've only been 3 or 4 of these ejection events, so I guess they just feel that they have to be pretty unlucky to be in the wrong place when one happened to come.
Wrong place at the wrong time.
Much of the stuff that's ejected, by the way, doesn't leave the asteroid's gravitational field, even though the asteroid's gravitational field is very low. It sort of flies around the asteroid and then lands around the backside somewhere. Only a little bit of it is ejected into space.
Right. Okay, final question here from Neil McLean. Maybe I missed it. Oh, no, another question just popped up. Maybe I missed it, but what was the estimated mass of Ryugu?
You didn't miss it because I didn't say, and I can't remember off the top of my head. However, we could work it out. It's 900 meters in diameter. So we can get the volume, that's 4/3 pi r cubed, and the density is 1.2 times water, so it's just a bit more dense than water. So if you work out the volume and figure out how much that volume of water would weigh, that'll tell you the mass of the asteroid. I can't do that arithmetic in my head.
I couldn't do it on a bit of paper, so don't worry.
I suspect it has to be quite a large number, but it's probably millions of tons. That would be the way to work it out, is to get the volume, and the density is 1.2, so it's just a little bit denser than water.
Okay, a question from Ian. What tests will be carried out on the particles when they are returned?
I don't know. That's cosmochemistry, and it's not really my thing. I can imagine they'll be doing things like radio dating if they can, and looking for isotopic ratios, which might give you a clue as to where the stuff's come from, and trying to get the chemical composition as accurate as possible. But there are hundreds of these asteroids, and it's very difficult if you can't afford to send space missions to all of them. So what they will try to do is correlate the chemistry of the dust particles with the spectral characteristics of the asteroids, and then we can look at the spectral characteristics of other asteroids and try and figure out what the other asteroids are made of. But it must be the sorts of stuff you need fancy mass spectrometers and that sort of thing to do. Things that are too complicated to put on the spacecraft itself. Gotcha.
Okay, one from Steve. When the lander got there, if the gravity had been significantly more, would it still been possible for it to be for a return journey? Basically, would it be able to lift off again?
Yeah, because it's these things are tiny.
I'm guessing it'd been worked out beforehand as well.
Yeah, you don't so much land on them as dock with them.
Mm.
And the fact that their preferred landing mechanism was just to drop the thing from 40 meters and let it free fall onto the surface tells you that the gravitational field is very, very small. So I think they probably had quite a lot of margin.
Right, just one last one here from Alan Kennedy. This is up to you if you do it or not. Is it possible to share your PDFs with the attendees?
I don't see any reason why not. All of those pictures I showed, with the possible exception of the shark's fin, are public domain photos. I mean, I just downloaded them all from the JAXA or the NASA websites. There are excellent websites for both the Japanese Space Agency and the OSIRIS-REx mission page. I mean, I showed you 2 or 3 photos. I could have shown you 50. There's bucket loads of stuff that you can download, but I don't see any reason why not. I'll have a quick check through it just to make sure it's kosher, and then I'll send you a link or something, Pete.
That's fine. I can pass it on to everyone else. Okay. Well, I want to say thank you very much for that. Really interesting. As I say, we can always judge a good talk by the number of questions we get at the end. And that's quite a few there. I'm sure there's other people wanted to come in. But we'll take a bit of break. But before we do, I know you couldn't make it up to us, but I want to send this to you. This is a little glass with Sigma on it. It's a whiskey tumbler. So maybe you couldn't get up to Moray, but maybe you can buy something that was made in Moray, put in the glass, and have a taste of Moray.
Yeah, you're very kind. I think you gave me one of those last time too, and so I'll have a pair now.
You have a pair now. But I say, if you just drop me an email with your address on you want it sent to, I'll get it in the post as soon as I can for you.
Okay, super. And sorry I couldn't make it. I look forward to coming up.
When you get up here next time, let us know and we'll meet up and we'll get down to Moravia maybe and meet down there in the planetarium.
The world's come back to normal. In the meantime, everyone keep safe.
Yeah, brilliant. Okay, we'll take a quick sort of 10-minute break then. You're quite welcome to stay along. Let's say, and after the break, let's say Stuart's going to give us the space news. Then I will give you a little bit of club news, and I'll share you that picture of Venus and the Pleiades I took last night, and explain about that really expensive piece of equipment I made to take the picture so well. Okay, so we can all just hang on in here, go and get a cup of coffee, whatever you want to do, or I might go and get a dram actually. Why not? I'm not driving, and we'll see you back in about 10 minutes, about 9 o'clock. Okay.
Yeah, I'll pop in. I'll stick around for a bit. Although I think I'll go and have a drink.
I don't blame you. Don't blame you.
Mark, is it okay that I pop out to grab a cup of tea?
Yes. Can you hear me? Yeah.
Yeah, I can hear.
Okay. Yes.
Shall I hand you the host?
You can do that, but I wanted to sign off soon. But if you grab your tea and then I will sign off afterwards, that's fine.
Okay, super. I'll hand you the host. Okay, Mark, that's me back. If you want to hand the host back to me, then you can go if you want.
Okay, Martin, you have the host back. You've got it?
Yes, I have. Thank you.
Okay. Have a nice evening then.
Yeah, you too, eh? Say hello
very...
there, and we'll see you soon.
Yeah, speak soon. Bye.
Bye-bye.
It's, I don't know, half a mile in diameter or something. So nothing's turned up that has a likelihood of striking the Earth for 100 years. Now, that doesn't mean to say something we haven't seen at all won't just come like a bolt out of the blue, but right now there's no known object that's likely to strike the Earth at a level of causing a mass extinction anyway in the next 100 years. So I suspect it's not high on most people's radar. There is a mission planned in the near future. I think it's an joint ESA-NASA mission to experiment with asteroid deflection techniques by hitting one with a small impactor, and then another one where they will try to use they'll try to put a spacecraft in very close orbit with it and use the spacecraft's mass itself to try and drag the asteroid away slightly. So that there are some experiments going on this level, but I don't think it's a sort of thing that people will take seriously until we know for sure it's happening. I always had, you know, I don't want to get political here, but I do remember years ago thinking that if Margaret Thatcher had ever been told that an asteroid was going to strike the Earth, she would say, well, if it's important, private industry will do something about it.
Okay. I see another hand going up. Pete, do you want to take one more question?
Let's have one more
microphone?
question. And, yeah,
one more question via microphone.
Then we'll carry on with the second half.
Okay. So I don't know what your name is, but you have got a number instead of a name. Your microphone is on.
I'm John from Aviemore.
Oh, hi, John. How are you?
Very well. Glad to take part. Can I ask a question?
Yeah, John, fire away.
Please could you tell me how this exploration affects the formation theories of Phobos and Deimos? Because one of the two theories is that they were captured asteroids.
Yeah, I think they probably are captured asteroids.
As opposed to a grand collision theory.
You mean a collision which ejected them from Mars itself?
A collision with Mars, yes.
I don't think that.
Because I've given a talk on Phobos and Deimos.
Well, it's not. Truthfully, it's not really my subject. When I do science at all, I tend to be an observer, and I tend to look at, what color is it, how fast is it rotating, how big it is, and the theoretical stuff I leave to people who are better at maths than I am. So, if you were going to form, well, I mean, people think that the moon was formed by a big collision with the Earth, but it doesn't blow off a piece the size of the moon. It blows off a lot of debris that then recoagulates to form the moon. Now, Phobos and Deimos aren't all that big. They're a couple of 10 kilometers across or something. honestly don't know. Now you ask the question, that's a good question actually, because I don't think we have any really high resolution photographs even of Phobos and Deimos. I mean, I remember the ones from Mariner 9 and from the Voyagers, from the Vikings, but there hasn't been a close up flyby of either of the Martian moons to see what they're like at a small scale. So I'd have to.
Okay, well, thank you very much, because I managed to get the conference about the moons 3 years ago, international conference.
Yeah.
So thank you very much.
Okay, well, sorry, I couldn't really give you much of an answer, but I'd rather admit I don't know than trying to bluff my way through something I don't.
Okay, thank you.
Okay then.
You're going to use society news and your space news?
Yes, we're going to go on to the second half to say what we'll do. We'll start off with the space news, and then we'll do a bit of club news, and then we'll just have a little bit of feedback. I think Martin's going to explain how the feedback's going to work. Is that correct, Martin?
Yes, I will.
Yeah, you will later on. Okay. Okay, so we'll hand over to Stuart with the space news. Please, Stuart.
Yeah, we can see your slides, Stuart. I've trawled through publications and documents a week ago. I think your microphone needs to come down. Your microphone of your headset is, I cannot, we barely hear you.
Well spotted. I'd put it up while I was listening. Can you hear me now?
Yeah, that's better.
I talked through the documents and books last week to get information, and then I noticed this week a lot of it has changed because of things that are going on. A lot of the non-essential launches have been delayed. What's going on at the moment is those are essential for the ISS supply and military security, the main ones that are keeping their program. But what I looked at was the following I've got up here: OneWeb Communications, SpaceX, the military AEHF, the James Webb, equipment on the James Webb Infrared Telescope, and just a note on Comet Atlas. Right, on the 21st of March, the Soyuz, the Russian rockets, launched OneWeb's 34 package of communication satellites, which was a second batch, or a third batch, in fact, from what they've already done. And if I put it up there, well, it's the third flight for OneWeb's internet satellite constellation, and the second this year. And the first 6 satellites were launched in February 2019, with another 34 satellites lifting off February this year. They're putting them into polar orbit at 280 miles above Earth, and then they'll eventually head up to the 745 miles. And ultimately, OneWeb aims to launch at least 650 satellites. And I'll mention something about this afterwards. Into low Earth orbit to form a constellation designed to provide internet service to customers around the world, but they're a long way off to meeting that number, as they've only got up to 74, and they're a long way off meeting what SpaceX has done, which we discussed last month, if you remember. That's one of the satellites, an artistic illustration, and they used this launch to commemorate the world's first spacewalker, Alexei Leonov, 55 years ago, which is interesting how far we've moved since that first happened. Now, I put in here, because they're putting these satellites into low Earth orbit, I just sort of define what the orbits were. The low Earth orbit covers the area 125 to 1,250 miles. And pieces of space junk in this region are impacted by the atmosphere, which degrades their orbit and drags them back to Earth sooner. This is the prime realm for piloted spacecraft due to its easy access, like Virgin's galactic spacecraft. Navigation and communication satellites tend to prefer a semi-synchronous orbit, 6,000 to 12,000, and satellite communications, weather satellites orbit in the geosynchronous Earth orbit over 22,000 miles high and can remain aloft for millions of years. The lower orbit gives less time for the object to remain in space before returning to Earth. Now, put in at this point, OneWeb filed for bankruptcy on Monday after they'd done the launch. They've been trying to get funding from their investor SoftBank from the beginning of the year, and they filed bankruptcy under Chapter 11 of the USA Title 11 bankruptcy code, which means they've either got to reorganize, withdraw their filing for bankruptcy, or put in a Chapter 7, which is going to liquidation. They still, under Chapter 11, they still run the business. So at the moment, there's a lot of uncertainty about what they're doing. And the reason for the failure to get their investment was put down for the coronavirus that SoftBank just binned their application. So what I thought, we spoke also last time about the amount of junk in space. If nothing happens with their funding, then there'll be all these extra satellites in low Earth orbit. And when you look at what's in there, you'll see that since 1957, when the first rocket went into space, although it returned to Earth sort of 3 months afterwards, it kicked off a start of putting items into space, and we're getting left in space. Inactive satellites, upper stages of launch vehicles, discarded bits left over from separation, and even frozen clouds of water and tiny flecks of paint all remain in orbit high above Earth's atmosphere. When one piece collides with another, even more debris is released. Over 21,000 pieces of space junk larger than 4 inches and 500,000 bits of junk between 1 centimetre and 10 centimetres are estimated to circle the planet. The number is predicted to go up. That's where you can see the space junk around Earth. There are also millions of pieces of debris smaller than 1/3 of an inch or 1 centimetre in lower Earth orbit, and these objects travel at 4 miles per second. And at that speed, a tiny fleck of paint has the same punch as a 550-pound object traveling at 60 miles an hour. So you can see the danger this can cause as we go on, unless we start clearing these things out of the low Earth orbit, but any orbit. And despite the small size of most of the objects, the US and the Russian military are able to track a great deal of this junk up to 4 inches, and as it can be seen on radar and optical telescopes from Earth. And when preparing a launch, mission controllers screen the predicted post-launch orbit for potential collisions to avoid as much damage as possible. And similarly, craft such as the space shuttles and the International Space Station can change their orbits if large objects approaches. So that's becoming a major problem, and I can see that getting bigger as time goes on. SpaceX has had a bit of a checkered couple of weeks. That's the Demo 2 vehicle. Last March in 2019, it did a unmanned crew vehicle link up with the ISS, which was first of its tests. It is now due to do a second test in May this year. Well, that was the plan. And I think the current virus issue is probably going to delay that as well, because people are being laid off. But in addition, they had a problem arose on the 24th of March when they tried to prove the vehicle's parachute system. They hoisted a Crew Dragon capsule underneath a helicopter, and the idea was they'd take it up to a height, release it, and the parachute would open and it would come down to Earth. What happened was it became unstable under the helicopter. The helicopter pilot became rather concerned and jettisoned it, but it was jettisoned before it reached its target height, and therefore the parachute system wasn't primed, and they lost the vehicle. SpaceX's view on that was, well, the parachute system wasn't at fault, and therefore we can still continue with the with the next flight. But NASA and SpaceX are now working together to determine whether the testing plan going forward in advance of the Crew Dragon's second demonstration mission is possible. But that was only the second anomaly that that had in a week that could affect the timing. The other involved a Falcon 9 rocket, which takes the Crew Dragon up to the ISS. On March 18th, one of the 9 engines on the Falcon 9 first stage suffered a problem during the launch of 60 of the company's Starlink internet satellites. It managed to deliver the satellites into orbit, but it's not going to launch another Falcon 9 before conducting an investigation, and NASA is participating in that investigation. So I think those 2 issues, plus the coronavirus, is going to delay their May next test for the two astronauts who are supposed to be going up to the ISS. They've also had an issue with the Super Heavy, but if we look at the history of what SpaceX are trying to do, Elon Musk founded SpaceX in 2002 primarily to help humanity settle on the Mars, as his words. And the company is developing equipment to do just that. A giant rocket called Super Heavy and a 100-passenger vehicle called Starship. And there's a still from a SpaceX animation shows Starship launching on a Super Heavy rocket. And that's the Starship airborne after the launch. Again, an illustration. SpaceX's newest prototype, version SN2 of the Starship, passed a crucial cryogenic pressure test on the 8th of March at its South Texas facilities, paving the way for the next step. However, prior to that, they managed to destroy SM1 on the 28th, overnight on the 28th or 29th of February during its pressurization check. And it blew up. They pressurized it, and there was a complete failure. All they found afterwards was a pile of mangled metal and bits and pieces, which was not good. They also announced now that they're going to make some changes to the stainless steel that's used from 301. They haven't declared what that steel is going to be. 304 is obviously another version of the current one, but I think they're actually going to produce a completely separate version of stainless steel. They've been given permission, or secured permission, to begin construction of Starships at the port of Los Angeles. And the aim is to create a rocket capable of eventually carrying humans to Mars with up to 100 passengers on board each flight. It intends a new SpaceX factory to produce one Starship rocket every 72 hours. Now, I find this quite amazing. I know Elon Musk is very optimistic in his timelines. That fast rate production will be required if Elon Musk is to achieve his goal of carrying hundreds or even thousands of people to Mars. The aim is for the Starship to be reusable in a fast, efficient manner, with each individual Starship capable of being launched up to 3 times per day. I think that's even better than EasyJet. And it's designed to be relaunched an hour after landing with 0 nominal work, Musk has said. The only thing you expect to change on a regular basis is the propellant. And that's his idea of the Mars base, or Mars City, which he has in his view to occur in about 2028. I thought it's over optimistic, and I thought, how many people would want to go to Mars? And I thought of the current situation we're in. There might be quite a lot of people want to go to Mars to get out of the way of what's happening on Earth at the moment. But it's an interesting view, and NASA also have a view that they want to get to Mars or settle on Mars, but they've got their own space launch system, the mega rocket as they call it, which has been subject to delays and over budget. But they said they're not going to commit themselves to SpaceX's rocket until it's proved that it's actually flyable. But SpaceX's view is that by next year, they should be able to launch satellites with it. The year after, they'll do an orbit around the moon. And then after that, they'll be ready to go to Mars. And the first two rockets that go to Mars will be unmanned, but will take supplies. And they're going to set up a base to use the ice, water, and carbon dioxide in the atmosphere to produce methane and oxygen for the fuel for the return. Grand ideas. This is the one that was given permission to launch. This is the advanced, extremely high frequency military communication satellite. Donald Trump in December last year set up the Space Force, which, like the Marines, is part of the Navy. The Space Force is part of the Department of Air Force in America. And its role is to defend satellites and also provide cover in terms of video and communications for the American forces operating anywhere in the world. And this is a geostationary satellite which was launched. And that's it on its launch pad from Cape Canaveral. And I'll go through a set of images showing how it got to its final orbit. It exceeds the speed of sound flying east from Cape Canaveral Air Force Station. It passes through the region of maximum dynamic pressure during the ascent through the lower atmosphere. And having burnt off propellant approximately 15 seconds earlier, the 5 spent Aerojet solid fuel boosters are jettisoned. Then they're jettisoned in a particular sequence, you just see there. First pair, and then followed by the second and third, and half later by the remaining 3. It gets rid of its payload fairing, and that's once the external heating levels drop below a predetermined limits after climbing through the dense lower atmosphere. The RD-180 main engine completes its firing after consuming its kerosene and liquid oxygen fuel supply in the Atlas first stage. It separates from the Centaur upper stage. The Centaur engine ignites for the first of 3 upper stage firings. This burn will inject the Centaur stage and the satellite into an initial parking orbit, which it goes into. And the Centaur engine shuts down after arriving in the planned low Earth parking orbit. And it enters 11-minute coast period before arriving at the required location in space for the second burn. And ignites to accelerate the payload into a highly elliptical transfer orbit from the parking altitude achieved earlier, and the burst lasts for 6 minutes. And again, second firing takes place, 5-hour coast period, and at that time it also releases a second small payload satellite, which is used for alignment and support. And after a 5-hour coast, reignites for a roughly 1 minute, 28-second firing to place the satellite into the proper orbit for spacecraft separation. And it's concluded as the Centaur reaches the planned elliptical geostationary transfer orbit. And that's it, put in place. Which is quite a complicated process of getting into the orbit. That one, that's now, it's provided by Lockheed, and it's 15 billion network made up of 6, and the last one is the 6th one, satellites. First one launched in August 2010, second May 2012, September 2013, October 18, August 19, and then this one, and they all are lifetime of 14 years. And at the moment, it's the only one that's considered critical under US national security. So that's space, that's the military. The James Webb Space Telescope has done one of its first tests, which is erecting the aerial, which is a little bit like origami, to get it into a 16-foot rocket. That was set up. They've got one further test to do, which is the stand that it fits on. They're going to do, but they've started standing their employees down, and after they've done this second test, they're going to close the factory until further notice, until they sort out what's going to happen. But you can see the size of that. That's 21-foot aerial, and it fits together like an origami when it folds down. This one, for those who sat in the BAA conference with Nick James, this is Comet Atlas. Now, I took some of this from the Times, and I know what Nick James said about newspaper reporting on it, but it actually just shows the trajectory of the Atlas comet. As you see there, it goes between Earth and the Sun. And there's a shot of what it would look like, the top left-hand corner. And this I thought quite useful, because that was also in the Times. It shows from now, early April, is where you can actually see it. And I don't know whether anyone's actually been out to have a look to see whether they can see it, but you should, according to what I've read, not just in the papers, but you should be able to see it with binoculars or the naked eye at some stage. But I take what Nick James was saying, that it may not be as visible as the newspapers are reporting, or as good as the newspaper reporting. But you see at the bottom there, the closest to Earth is on May the 23rd. So it's late in May, you might get a better view of the comet. And if anyone sees any aliens, you best report them. That's it. Thank you.
Thank you very much, Stuart. That's brilliant. Yeah, to say just one thing about the comets there. I remember, I think it was Sandra Branton who told me, the comets are like cats. They both got tails and they're totally unpredictable. So we just have to watch.
That's why that was in the paper. I didn't put that bit in, but that was in the paper.
It's something that's always stuck in my brain to say. But okay, we'll move on with, just before I go to the club news, one participant we got on here is a friend of mine called David. I asked him to join because he's actually deaf, and he's got a bit of software he's been using. Sorry, do you want to just send your?
Yeah, just hang on. Okay. Yep, there we go.
Okay, yeah. So say he's actually deaf, and he's been using a bit of software to transfer everything we've been saying into text. So he's been able to follow the meeting all the way along. So I've been wanting to get him on board with Sigma for a long time, because I know he's into astronomy. I have a few drinks with him down the pub as well. So this is another show in what a good piece of kit this actually is, to include other people, which is what Sigma's all about, is to try and include as many people as as you possibly can. Right, I'll show you this little picture of Venus and the Pleiades that I took last night. Now, I've often taken pictures of Venus with a camera, and it never looks very, very good. So I had an idea last night to actually see if I can get these nice star points coming off of Venus. So you can see you've got Venus here, really, really bright. You cannot miss it in the sky if you go out sort of after twilight. And it's nestled here in the Pleiades. That's where it was last night. I say this is taken with a 300mm lens with an ISO with 3200 and just 2.5 second shot at f5.6. So I've tried different exposure, but this is the one that sort of brought out the best. Now, to get this lovely, lovely pattern of of the spikes, like I said, I use this very, very expensive piece of kit. And we'll just show you what it is. I've already painted this, by the way, so if you want to make one of your own, you're gonna have to pay me for it. And this was it. Basically, what I've got is two pieces of wire. It's wire that my wife uses to make jewelry with, and 4 pieces of blue tack around the outside around here, just holding it on. And by doing that, it causes the light to diffract, and it gives you those lovely spikes. Otherwise, you just got like this great big bright blob in there, and it doesn't look half as good. So, just a little tip for you if you want to have a go at some brightish stars and and get those spikes on it.
Yeah, and that's the same reason why lots of professional astronomical imagers have those streaks. It's because the secondary mirror,
the spider. Yeah, that's right. That's right. So I've got a Smith Newtonian, which doesn't obviously have that, but I'm thinking about doing the same thing on my telescope once I get out there. Okay, a little bit of club news. As I say, the BAA event was planned for the 4th of July. Obviously, that's been postponed. It was cancelled, but it's now postponed up until it's going to be on the 26th of June, 2021. Okay. Refunds for the ones of you who have actually bought tickets already will come back to you, and it'll start afresh again next year. The refunds might take a little while because the person who handles all the refunds and collection of money actually went down with the virus a couple of weeks ago. So bear with us, but the money will come back to you. Okay. What else we got? Not much. Just to say about your membership renewal. I think most people have actually paid now from what I've seen on the spreadsheet the other today actually. But obviously we've got the AGM coming up. We are going to hold it probably by Zoom as we are here on the webinar. But we need, if you want to vote in the AGM, you need to be paid up by about the 20th of April because that's when all the voting slips are going to go out to the paid members. Okay. So we're going to do it a little bit differently, obviously, so we can't meet up. We're going to send out all the voting papers first, and we'll need them back. I think I've got the date down for the 20th of May, I think it is, to give us time to count them and get them sorted, ready for the meeting. Right, the future of the webinar, as I say, we have actually now purchased our own account, so we can carry on doing this for as long as we possibly need to or want to. We might actually, even when we get back to normal, actually stream the meetings from the hall. So people who can't make it or are affiliated members like over in say North Ronaldsea, whatever, or has, can come along and join in the meetings without having to jump in the car and come down to us personally. If you want to come down personally, please do come on down. To say another thing we're thinking about doing as well is with the Zoom account, we're thinking about we could actually share this between clubs if other clubs want to do this. I'll go out to some of the other clubs, North Ronaldsea, Aberdeen, obviously, in the next couple of days, and just put some feelers out and see what you're thinking. And if you want to come on board, we can always host it for you, and you can run your, you can run your meetings by this. Share the cost. It's all going to help because it's not free. This, believe me, it isn't free. Yep. Let's say the how-to section. We can't do that because we're not actually. Well, actually, that one thing I'm thinking about doing is to actually run another meeting, more of a meeting than a webinar next week, where I was going to say I was going to do these website reviews. I think it's going to be easier to do this on here than what it is actually in the hall. So I think what we'll probably do is I might just organise one, send out the invite, and I'll probably do Heavens Above, because I went into it last night and there's a lot of new stuff in Heavens Above, and it's really, really handy to use, and it's quite simple to use once you know what you're clicking into. So keep an eye on your inbox. I'll probably send something out maybe Monday or Tuesday, something like that. Okay. Right, obviously the committee, anyone wants to come along the committee, now's the time to put your names in because we can vote you in at the AGM in June. It's not difficult. The more people we have, the easier it is. Going on to the next meeting, as I say, we're pretty sure it is going to be on the webinar. Not sure if Robin Catchpole is still here. I'll just have a check. No, I think he's gone. As I say, at the minute, he was going to be joining us from Cambridge, but he's actually in lockdown in South Africa at the moment. So we might have to come from South Africa. That's where he was joining us from tonight. So keep an eye on it. We'll hopefully get him on board, and then we'll stream his talk from South Africa or Cambridge. If he can't make it, then we'll obviously do something else. But we will have a meeting next month. Okay. And I think that's everything. Obviously, if you've got anything for me, you can contact me through the website. Just click my face on the meet the committee, and my email address will pop up, and just send me any questions or any sort of feedback on tonight as well. Be good. Martin, you're going to talk about the feedback?
Yes, very briefly, what I'd like to do with you guys, for those people that have are left here, including panelists, I'm going to launch a little poll. And if you could just please answer those questions for us, that would be really super. So if you would like to give us your answers, there's 4 questions, and it's just to see what you thought of tonight's what you call it, meeting using Zoom.
Experiment. You can call it an experiment.
Yes. Yeah. I don't know. I'm not seeing anybody yet voting, so I wonder whether or not people can see this. Because that's really odd, because we had the same problem the last time. It says attendees are now viewing. Okay, can anybody raise their hand of the attendees who can see the poll?
The chat says no.
No, nothing to
say
see.
Nothing yet.
Okay, now we have a problem. What I would suggest is that we will send, we'll email the questions. This is really odd. Okay. Right, I'm going to just end this because nobody seems to be able to see this, but it's really strange. It worked. Yeah.
We'll work it out. We'll work it out. Right. Yeah. So if we're going to end here, I'll say thanks, obviously, to John for coming. Well, not coming along, but joining us. Thank you, John. And I say, if you come up, give us a bell, and we'll meet up down at Moravia maybe. And everyone for joining online, because as I say, it is an experiment. I think it's gone. I feel it's gone quite well, and I hope you have as well. So please let me know. Just send me a little thing, say how you think, and we'll send out that questionnaire as well. So thanks everyone for coming along, and keep an eye on your inboxes. I'll send something out next week, and we'll do something online together and keep busy. Okay. Thanks, everybody. Bye now. People are still there.
So the one thing I would be interested is that my PR person who does our Twitter accounts and stuff would be interested to know from you how it went. I'm not asking you to send a message that says, please give John a bunch of flowers, but if this sort of thing is a viable way of doing this, then we, the observatory, could probably do quite a bit of it. So I think as far as I know, I'm the first person to try doing this. So if you had some sort of something sensible we could put on Twitter or something, I'm sure Eve would be happy to know. Anyway, good. Thanks very much, guys. It was good. It was great fun in the end. I'll happy to work with you again another day, and I'm going to sign off now. Bye.
Bye, John.